Hey Lisa, so couple of ways of looking at this one. Um, if we use the subtraction property, so there's that one property that says if I have like a to the x over a to the y, it's a to the x minus y. So if I do that one, then this would become 4 over 8 p to the 4. Remember, when there's nothing there, it's an invisible 1. T to the 5 minus 5, and W to the 5 minus 6. I think that was the one that was causing you some trouble. 4 over 8, I could reduce to 1/2, so I'll go ahead and do that. 4 minus 1, that's going to make P to the 3rd. 5 minus 5, that's going to make T to the 0, and I'll clean that up in just a second. And W, so that'd be 5 minus 6, so that would be W to the negative 1st. So using the subtraction property for division, that's where I get to. There's a little bit of simplifying left to do. When I have a positive exponent, that means it's in the numerator. When I end up with a negative exponent when I'm doing the subtraction, that means it belongs in the denominator. So let's set up a fraction. The p to the 3rd is up in the numerator. I could write this 1 out front, and if this had been like reduced to 2/3 or something, I would definitely have the 2 there and the 3 there. But since it's a 1, I probably wouldn't write that. And I'll put the 2 downstairs. T to the 0, that's just 1, so I don't need to 1 times p cubed is still just p cubed. And then W to the 1st, remember there's that other property that says if I have a to the negative x, then that means that belongs in the denominator, and it's a to the x downstairs. And basically what this property does is if you have a negative in the numerator, it should be in the denominator. If I end up with a negative in the denominator, it should be in the numerator. So that would bring that W downstairs. And again, you could think of that as W to the 1st, but we usually don't write that 1. So that would be kind of the most simplified form of the answer without the 1 p to the 3rd and the 1 on the exponent. That's one way of looking at it. Here's how I would do it. So that's using subtraction property. If you have all positive exponents, you can also just kind of think of it as reducing. So if I have 4 up and 8 down, if I reduce that fraction, I'm going to have 2 in the denominator. If I have p to the 4th up and p down, so think of that as there'd be 4 p's up and 1 down, and I'm canceling, and so I would have p cubed left in the numerator. T to the 5th over t to the 5th, that just cancels, that's 1. And by the same logic as with the p's, if I had 5 w's written out here and 6 w's written out there, and I canceled out 5 of them, I would still have 1 w left in the denominator. So when I have all positive exponents, for me, I prefer to think of it as canceling, and then I don't kind of end up with the weird t to the 0 and w to the negative 1. But it is the exact same thing in terms of this w, and we get a negative because it was supposed to be in the denominator. This version can be handy when you have a lot of negative exponents floating around the problem. This just gives you I do this and I see where it lands, and if it's positive, it's in the numerator. If it's negative, in the denominator. But since this original problem was all positive exponents, to me this one's easier to look at as just a cancel. Let me know if you have more questions in this section with the negative exponents. Lots of people have lots of questions, so feel free to post, or if you want to meet up, let me know.